Hello guys, my name is Zachariah Shahideen. Today is the 3rd of December 2025. This is my structure elucidation video. I was put into group 7, letter G, and my molecular formula is C9H12. Starting off first with my IR spectral plot, we have 3 distinct peaks. The first one being located at about 1500 centimeters, the -1, wave number of 1500, that would correspond to an aromatic. The second one being 2850 to 2960, that's more characteristic of an alkane sp3ch stretch. And finally the third one would be an sp2ch stretch, so something that has an alkene or aromatic character, probably an aromatic, and that would be 3000 to 3100 centimeters wave number. You can reference this table right here. Okay, so we know based off of this, tabulating this, matching back to the table, 3000 to 3100, these values would align with these functional groups. Analyzing our carbon 13 NMR, we count 1, 2, 3, 4, 5, 6, 7 distinct carbon environments. Most notably, I see something between 110 to 170 chemical shift parts per million. You could reference this table right here. Okay, that would be the aromatic. And
aromatic structures, most notably benzene, has a circulating pi electron cloud. When an external magnetic field is applied, this creates a secondary magnetic field affecting the benzene carbons. This anisotropy de-shields the carbons, pushing their chemical shift downfield 110 to 170 parts per million. The chemical shift is influenced not only by aromatic anisotropy, but also by polarity. The propyl group slightly donates electron density into the shifts of the ortho, meta, and para carbons.
And this over here, let's reference this table. That should be your alkyl groups. Finally, the most telling one, in my opinion, that I feel like is going to answer this problem even without these spectral plots over here, but this also gives me the confidence to know that that is indeed the C9H12 I'm looking for. Looking at this, we know that anywhere between 6.5 to about 8 ppm, that would be characteristic of a benzene ring or aromatic ring, however you want to call it. You can draw this right here. And we know we have 5 hydrogens, so we know that there's something here that should be occupying it. Looking at this one is very telling. This is a 2 hydrogen and it's a sextet. So drawing carbon, I know it's a carbon because at around this ppm range, you should have alkyl groups. To be sure of that, I'll reference this. Okay. So CH, 2 hydrogens. Using the n+1 rule, since this is a sextet, I should have 5 neighboring hydrogens. So this is a plausible structure right here. Right? Counting this, so 2 hydrogens, 1, 2, 3, 4, 5, n+1 rule, 6, that's a sextet, that works out. 3 hydrogens should find the triplet in this. So here we have 3 hydrogens, 2 + 1, n+1 rule, triplet. And finally right here, 2 hydrogens, 2 + 1, we have a triplet. So this checks out, so we're good here, good here, good here. Putting pieces of the puzzle together, we're gonna take our benzene ring, we're gonna take our alkyl group, our propyl group specifically, right? And we would get this structure. Okay. I have this tabulated here, this table. So the table that I inserted earlier in the video, you'll see that here I have 7.3 ppm, 2.7 ppm, 1.6, which would be our alkyl group, 0.9 to 1.1, also an alkyl group. My integration, 5 hydrogens, 2, 2, and 3 hydrogens. We have our multiplet, triplet, sextet, and triplet, and this is the interpretation. You can see our benzoylic methylene right here. We have that. We have our sextet, and this CH3 corresponds to that CH3. Putting it together, we get compound propyl benzene. All right, and now just to make sure that we do indeed have the compound of interest, we have to make sure that first it matches our molecular formula, C9H12. So let's look at that really quick. Okay, so here we go. Hydrogen, 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 hydrogen. Let's count how many hydrogens we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 3 is 12. So we have 12 hydrogens, so we're good there. Let's see how many carbons we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we have 9 carbons. So do we have C9H12? Yes, we do. All right, let's make sure we have 7 carbon environments, right? Our 7 carbon environments. That's the first one, second one, third one. This is the fourth one, fifth one, sixth one. Am I missing one? 1, 2, 3. Oh, yes. I forgot this. That 7th one's right here. Okay. That's called the ipso carbon. So, yes, we do have this. We are matching that, right? This over here corresponds to these carbons right here. And these alkyl groups would be this one. This corresponding to that. The ipso carbon responding to this. The ortho carbons here. The meta. So ortho, meta. These are the meta. This is the para. This over here would be the CH3 group right here. This is the methylene, CH2. And this is the middle CH2. Okay, I have it on that table. Right there. So make sure, so that is good right there. Make sure our functional groups, we have those 3 functional groups, as well as our 1, 2, 3, 4 hydrogen environments. Let's see if we have the same 4 hydrogen environments. So that's 1, that's 2, that's 3, and these 5 hydrogens fall under this environment right here. So that's 4. Without reasonable doubt, C9H12 is very much likely to be propylbenzene. Something I overlooked in my primary analysis was the index of hydrogen deficiency, also known as the degree of unsaturation. You would typically carry out this calculation before looking at your spectral plots, just to make sure that the result we got in our spectral plots line up with this equation. We're going to go ahead and calculate what our IHD is. Using this equation, 2, we have 9 carbons, plus 2. We don't have any nitrogen atoms, so that will be 0. We have 12 hydrogen atoms, so put 12. And we have 0 halogens, so it will be 0. Altogether, 2 times 9 is 18. 18 plus 2 is 20. 20 minus 12 is 8. Divided by 2 should be 4. So that confirms our 1H NMR chemical shift of about 7 to 8.5, which is where most aromatics would be. So that would be characteristic of our benzene ring. So we know for sure our degree of unsaturation being 4 will give us this benzene ring. And so if you like this video, share a thumbs up. Thank you guys.